Hello there, gentle souls, wherever you might be settling in for the evening. Welcome to another peaceful journey together, another quiet exploration of the wonders that surround us every day, often without our noticing. I'm curious, where are you joining me from tonight? Are you nestled in your bed in a small coastal town, perhaps hearing the distant whisper of waves against the shore? Or maybe you're in a city apartment, stories above the ground, where the only water nearby is the rain that's been pattering against your window. Are you in the mountains, where streams tumble down rocky slopes? Or perhaps in a place where snow is beginning to dust the landscape, each flake carrying its own quiet story? And what time is it where you are? Is the sun just beginning to set, painting the sky in those soft purples and oranges that make evening feel like a gentle sigh? Or has darkness already settled around you like a familiar blanket, with only the warm glow of your screen to keep you company? Whether it's early evening or deep into the night, you're exactly where you need to be for tonight's contemplation. Before we begin our gentle drift through tonight's topic, I want to paint you a picture of what awaits us. Imagine, if you will, that every drop of water on our planet is like a living library, not filled with books and pages, but with memories, chemical memories, thermal memories, memories of pressure and depth, and the company of countless other molecules over journeys that span not just continents, but millennia. Tonight, we're going to take the most leisurely of strolls through the ocean's memory palace. We'll discover how a single drop of water might carry within its molecular structure the story of Arctic ice sheets, tropical storms, deep ocean trenches, and mountain springs. We'll explore how the vast oceans serve as Earth's memory bank, storing information about climate, chemistry, and circulation patterns that stretch back through geological time. If you're enjoying these peaceful explorations into the wonders of our world, I'd be gently grateful if you could share that appreciation with a soft tap on the like button. And if you'd like to join me for more of these contemplative journeys, a gentle subscription would mean the world to me. But truly, your presence here tonight is gift enough. Now, I should offer a playful warning. Tonight's topic might prove to be almost too fascinating for sleep. We're venturing into territory where poetry and science dance together so beautifully that you might find yourself wide awake, marveling at the elegant choreography of molecules and currents and time itself. If that happens, simply let your mind drift along with the stories we'll explore. There's no urgency here, no deadline for understanding, just an invitation to wonder. So let's begin this gentle journey together, shall we? Let's discover how water remembers, how every sip you've ever taken connects you to glaciers and rainforests, to ancient seas and future clouds. Let's explore the ocean's memory, written not in words, but in the very essence of water itself. Let's take a gentle stroll through the idea of memory itself, and consider what it might mean for water to remember. When we think of memory, we usually picture neurons firing in complex patterns, or perhaps old photographs tucked away in dusty albums. But the ocean's memory is written in a language far more subtle and profound. It's encoded in the very atoms and molecules that make up each precious drop. Imagine, if you will, holding a glass of water in your hands. The water appears clear, simple, unremarkable. But if we could somehow zoom in with impossible precision, if we could see the molecular dance happening within that transparent liquid, we would discover something extraordinary. Each water molecule carries with it an atomic signature, a kind of molecular passport that tells the story of everywhere it's been. This signature isn't written in ink or etched in stone. Instead, it's encoded in the isotopic composition of the water itself. Now, don't let that scientific term create any urgency in your mind. Isotopes are simply different versions of the same element, like siblings in an atomic family. For water, the most important members of this family are regular hydrogen and its slightly heavier cousin deuterium, along with the common oxygen-16 and its heavier relative oxygen-18. The ratio of these atomic siblings in any given water sample tells a story as rich and detailed as any memoir ever written. Water that evaporated from tropical oceans carries one signature, while water that condensed from clouds high in the atmosphere carries another. Rainwater in the Amazon has a different isotopic fingerprint than snow falling in Greenland, and both are distinct from the ancient waters that flow from deep springs in the desert. Picture this process like an elegant, cosmic sorting system that's been operating for billions of years. When the sun's energy causes water to evaporate from the ocean's surface, it doesn't lift all water molecules equally. The lighter isotopes rise more readily into the atmosphere, like dancers who leap higher because they carry less weight. Meanwhile, the heavier isotopes tend to remain in the liquid phase, settling back down like graceful performers who prefer to stay closer to the stage. As clouds form and drift across the sky, this isotopic sorting continues. When precipitation finally falls, the ratio of light to heavy isotopes tells us about the temperature at which the condensation occurred, the altitude where the clouds formed, and the distance the water vapor traveled from its source. It's as if each raindrop carries a tiny barometric memory, a record of the atmospheric conditions it experienced during its journey through the sky. But the ocean's memory extends far beyond these atmospheric adventures. Deep beneath the surface, in the vast, slow-moving currents that circle our planet, water carries memories that span centuries and millennia. These deep waters remember the temperatures and salinities of distant seas, the chemical composition of long-forgotten glacial melts, and the atmospheric conditions that prevailed when they last touched the surface, perhaps hundreds of years ago. Consider the water that sinks in the frigid seas around Antarctica. This water becomes so cold and dense that it descends to the ocean floor, beginning a journey that will take it across entire ocean basins. As it travels, it carries with it the chemical and isotopic signature of its polar origins, a molecular memory of ice and extreme cold, that it will maintain as it flows beneath the equatorial currents, beneath the warm surface waters where tropical fish swim and coral reefs flourish. This Antarctic water might spend 500 years, 1,000 years, slowly creeping along the bottom of the Pacific, maintaining its polar memories even as the world above changes. Civilizations rise and fall, ice ages come and go, but these deep waters continue their patient journey, carrying their molecular memories across the planet's basement. The ocean remembers in layers, too. Oceanographers can read the water column like a book written in salinity and temperature, in dissolved gases and trace chemicals. Near the surface, we find the memories of recent interactions with the atmosphere, the signature of last year's hurricanes, the chemical fingerprint of spring blooms, the thermal memory of seasonal warming and cooling. Deeper down, the water holds older memories, like archaeological layers that speak of different eras in Earth's history. Perhaps most remarkably, water remembers through its ability to carry and preserve information about biological processes. The ratio of certain isotopes in seawater can tell us about ancient productivity levels, how much photosynthesis was occurring in the oceans millions of years ago. The chemical composition of deep waters can reveal information about long-extinct marine ecosystems, about the rise and fall of different species, about the chemical evolution of life itself. In this way, the ocean serves as our planet's vast memory bank, storing information not just about physical processes like circulation and climate, but about the entire history of life on Earth. Every major extinction event, every period of rapid evolution, every change in the global carbon cycle, all of these leave their mark in the ocean's molecular memory. As you drift towards sleep tonight, imagine yourself floating peacefully on the surface of this vast library of liquid memory. Beneath you stretch waters that remember ice ages and warm periods, that carry the chemical signatures of volcanic eruptions and asteroid impacts, that hold within their molecular structure the story of how our planet became the blue world we know today. You are connected to all of this through the water in your own body, through every sip you've ever taken, through the atmospheric moisture that surrounds you as you breathe. Let's take a gentle stroll now through the great highways of the sea, those vast currents that serve as the ocean's circulatory system and its memory transport network. If we imagine the ocean as a living entity, which in many ways it is, then these currents are its bloodstream, carrying not just water and heat and nutrients, but memories from one part of our planet to another. Picture, if you will, standing on a bluff overlooking the ocean on a calm day. The surface appears relatively still, perhaps with only gentle swells that catch the light like liquid silk. But beneath this peaceful facade lies one of the most dynamic and persistent transportation systems ever conceived by nature. Streams of water, some as wide as entire continents, flow through the ocean depths and along its surface, carrying their precious cargo of memories across thousands of miles and hundreds of years. The most famous of these liquid highways is probably the Gulf Stream, that great river within the sea that flows along the eastern coast of North America. But let's imagine this current not just as moving water, but as a flowing stream of memories. Water that began its journey in the tropical Caribbean carries with it the thermal memory of warm sunshine, the chemical signature of coral reefs, and the dissolved minerals of tropical rivers. As this water travels north, it brings these warm memories to places like Ireland and Scotland, which would be far colder were it not for this gift of tropical remembrance. The Gulf Stream is part of a much larger circulation pattern called the Atlantic Meridional Overturning Circulation, or AMOC, though we can think of it more poetically as the Atlantic's Great Memory Loop. Imagine this vast system as a slow-breathing cycle that spans the entire ocean basin. Warm, salty water flows north at the surface, carrying tropical memories toward the Arctic. As this water cools and encounters fresher polar waters, it becomes dense enough to sink, beginning a deep, slow journey south along the ocean floor. This deep southward flow carries polar memories, the isotopic signature of Arctic ice, the chemical composition of cold northern seas, the dissolved gases that speak of frigid temperatures and long polar nights. These polar memories travel south for hundreds of years, creeping along the bottom of the Atlantic, around the tip of Africa, and into the Indian and Pacific Oceans. Eventually, after journeys that span centuries, this water rises again to the surface, carrying its ancient polar memories into equatorial sunlight. But let's zoom out even further and imagine the global ocean as a single connected memory system. There's a circulation pattern that oceanographers call the global conveyor belt, but we might think of it as the planet's memory circulation system. This grand circulation connects all the world's oceans in one vast, slow-moving loop that takes roughly 1,000 years to complete. Picture this: water that sinks in the North Atlantic begins a journey that will take it around the entire planet. It flows south along the bottom of the Atlantic, carrying memories of Greenland ice and Norwegian fjords. Around the southern tip of Africa, it travels into the Indian Ocean, where it slowly rises and mixes with waters that carry memories of tropical cyclones and monsoon rains. From the Indian Ocean, our traveler continues into the Pacific, the vast blue heart of our planet. Here, it joins currents that remember Japanese typhoons, Alaskan glaciers, and the deep, cold waters that upwell along the coasts of Peru and Chile. The Pacific is so vast that water can spend centuries here, slowly mixing and exchanging memories with other currents, other water masses that have their own stories to tell. Eventually, our well-traveled water begins the journey home, flowing north through the Pacific, around the rim of the Arctic, and back into the Atlantic. When it finally returns to where it started, nearly 1,000 years have passed. The water has circulated the globe, carrying and exchanging memories, mixing its original North Atlantic signature with influences from every ocean basin on Earth. These great currents also serve as memory preservers, maintaining distinct water masses that can be traced across entire ocean basins. In the Atlantic, for example, there's a layer of water known as Antarctic Intermediate Water. This water mass formed in the cold seas around Antarctica, and as it spreads north, it maintains its unique temperature and salinity signature, its isotopic memory of polar origins for thousands of miles. Similarly, Mediterranean water carries the memory of that enclosed sea's warm, salty conditions far out into the Atlantic. The Mediterranean is like a natural evaporation pond, where the hot, dry climate concentrates the seawater, making it saltier and denser. When this concentrated water spills out through the Strait of Gibraltar, it sinks to a specific depth and spreads across the Atlantic basin, maintaining its distinctive Mediterranean signature for thousands of miles. These water masses are like letters written in the language of temperature and salinity, in isotopic ratios and trace chemical compositions. They carry news from distant seas, messages about climate conditions in far-off places, memories of ice sheets and desert winds and seasonal cycles in remote parts of the planet. The remarkable thing about these oceanic memory streams is their persistence. Unlike the atmosphere, where weather patterns can change in days or weeks, ocean currents maintain their character for decades, centuries, even millennia. They are the slow memory of our planet, the patient keepers of information about long-term changes and cycles. As you settle deeper into relaxation tonight, Imagine yourself as a water molecule beginning this grand journey. You start in the cold seas around Greenland, carrying the memory of icebergs and polar nights. Slowly, over centuries, you travel south along the ocean floor, through the darkness of the deep Atlantic, around the Cape of Africa, into the vastness of the Pacific. You rise and fall, mix and separate, always carrying your memories while also absorbing new ones from every sea you visit. This is the ocean's way of remembering, not through static storage, but through constant circulation, constant mixing and exchange. It's a dynamic memory system that connects every part of our water planet, ensuring that the chemical and thermal memories of distant places eventually reach every shore, every coast, every isolated island in the vast blue expanse of our connected seas. Let's take a gentle stroll now into the invisible library of the ocean, where stories are written not in words, but in atoms and molecules, in chemical signatures so subtle that we need the most sensitive instruments to read them. Yet these chemical memories tell tales more epic than any human chronicle, spanning not just years or decades, but geological ages. Imagine, if you will, that you could taste history in a single drop of seawater. Not literally, of course. The ocean is far too salty for that. But if your senses could somehow detect the minute chemical differences that scientists measure with their precision instruments, in that single drop, you might taste the remnants of volcanic eruptions that happened before humans walked the earth, the dissolved minerals from mountains that have since been worn to nothing, the biological signatures of creatures that lived and died millions of years ago. The ocean is, in essence, a vast chemical soup that has been simmering for billions of years. Every river that flows into the sea brings its own recipe of dissolved minerals: calcium from limestone caves, silica from weathered granite, iron from ancient volcanic rocks. Every underwater volcano adds its own ingredients to the mix. Every living organism, from the tiniest bacteria to the largest whales, contributes its own chemical signature to the ocean's complex composition. But here's where the ocean's memory becomes truly fascinating. Different parts of the ocean remember different chemical stories, and these stories are preserved in the slow circulation patterns we explored in our last gentle journey together. Water masses that formed in different places, under different conditions, carry distinct chemical fingerprints that persist for centuries as they travel around the globe. Consider, for instance, the chemical memory of biological productivity. In certain parts of the ocean, particularly where deep waters rich in nutrients rise to the surface, vast blooms of microscopic plants flourish. These tiny organisms, called phytoplankton, perform the same miraculous process as land plants. They use sunlight to convert carbon dioxide into organic matter, releasing oxygen as a byproduct. But when these organisms die, they sink into the depths, carrying with them not just carbon, but a whole suite of chemical elements that the ocean remembers. The ratios of different nutrients in deep water tell us about ancient patterns of productivity, about periods when the ocean was more or less fertile, about changes in the global carbon cycle that occurred long before humans began measuring such things. The ocean also remembers through the chemical signatures of different climate states. During ice ages, when vast amounts of water were locked up in continental ice sheets, the ocean became saltier, more concentrated. This increased salinity changed the chemical properties of seawater in ways that are still detectable today in certain deep water masses. The ocean carries within its chemical memory the signature of ice ages and warm periods, of times when sea level was much lower or much higher than it is now. Perhaps most remarkably, the ocean remembers the history of life itself through chemical proxies that serve as molecular fossils. The ratio of different nitrogen isotopes in marine sediments tells us about the evolution of nitrogen-fixing bacteria. The abundance of certain trace metals speaks to the oxygenation of the atmosphere billions of years ago. The chemical composition of ancient seawater, preserved in the crystalline structure of marine minerals, reveals how the ocean's chemistry has evolved over geological time. Let's zoom in on one particularly elegant example of the ocean's chemical memory, the story told by the element strontium. Strontium is a relatively rare element that dissolves into seawater from weathering rocks on land and from underwater volcanic activity. But here's the fascinating part. The isotopic composition of strontium in seawater changes very slowly over millions of years, depending on the balance between these two sources. During periods when volcanic activity is high, the ocean's strontium signature shifts in one direction. During periods when weathering of continental rocks dominates, it shifts in another. By measuring the strontium isotope ratios in marine fossils of different ages, scientists can reconstruct the history of these geological processes over hundreds of millions of years. The ocean remembers, through this single element, the rise and fall of mountain ranges, the opening and closing of ocean basins, the great cycles of geological creation and destruction that have shaped our planet. The ocean also carries the chemical memory of catastrophic events, asteroid impacts, massive volcanic eruptions, sudden climate changes. These events leave distinctive chemical signatures that can persist in the ocean for millennia. The element iridium, for example, is extremely rare on Earth's surface, but relatively common in asteroids. A spike in iridium concentration in marine sediments marks the asteroid impact that likely contributed to the extinction of the dinosaurs 66 million years ago. Similarly, massive volcanic eruptions inject unusual chemicals into the atmosphere and oceans. The Great Oxidation Event, about 2.4 billion years ago, fundamentally changed the chemistry of seawater as oxygen-producing bacteria began to dominate marine ecosystems. This chemical revolution is still recorded in the isotopic signatures of sulfur compounds preserved in ancient marine rocks. But the ocean's chemical memory isn't just about the distant past. It also records more recent changes, including those caused by human activities. The burning of fossil fuels has changed the isotopic composition of carbon dioxide in the atmosphere, and this change is now recorded in the chemical composition of seawater. The ocean remembers the Industrial Revolution, the nuclear age, even the specific years when different types of pollutants were first introduced to marine ecosystems. Plastic pollution, while visible on beaches and in gyres of floating debris, also leaves a chemical memory in the ocean. As plastics break down into microscopic particles, they release a cocktail of chemical additives and breakdown products that become part of the ocean's chemical signature. Future oceanographers will be able to read in the chemical composition of seawater the story of humanity's plastic age. As you drift towards sleep tonight, imagine the ocean as a vast chemical library, where every element tells a story, where every isotopic ratio speaks of ancient processes and distant events. The water that surrounds our planet carries within its molecular structure the memory of how Earth became the living world we know, a record of volcanic fires and asteroid impacts, of the evolution of life and the cycles of ice and warmth, of the very chemistry that makes life possible. In your dreams tonight, perhaps you'll swim through waters that remember the first breath of oxygen released by ancient bacteria, that carry the chemical signature of supernovas that enriched our galaxy with heavy elements that hold within their liquid, embrace the molecular memory of every raindrop that ever fell, every river that ever flowed, every tear that ever joined the endless circulation of our water world. Let's take a gentle stroll now into the deepest chambers of the ocean's memory palace, those vast, dark spaces where time moves differently, where water carries memories that span not just human lifetimes, but entire geological epochs. Here, in the abyssal depths, the ocean keeps its oldest secrets, its most ancient recollections of how our planet has changed over millions of years. Imagine, if you will, descending slowly through the water column, leaving behind the sunlit surface waters where waves dance and marine life flourishes in the golden glow of filtered sunlight. As we sink deeper, the light fades, the temperature drops, and the pressure increases. But most remarkably, as we descend, we're also traveling backward through time, entering waters that last touched the surface decades, centuries, even millennia ago. At about 1,000 meters down, we enter what oceanographers call the deep ocean, though we might think of it as the ocean's ancient library. Here, the water moves slowly, patiently, in great circulation patterns that take centuries to complete their cycles. This is where the ocean stores its longest memories, its most persistent recollections of climate states and atmospheric conditions from eras when the surface world was very different from today. Picture these deep waters as vast rivers flowing in slow motion through the darkness. Unlike surface currents, which can change direction with the seasons or respond to shifts in atmospheric pressure, these deep currents are remarkably stable, maintaining their character for hundreds or thousands of years. They are the ocean's long-term memory storage system, preserving information about past climate states with remarkable fidelity. The deepest waters in our oceans carry some of the most ancient memories. In the Pacific, the world's largest ocean basin, water that sank in the North Atlantic centuries ago finally rises to the surface, along the coasts of Alaska and Siberia, carrying with it the temperature and chemical signatures of long-ago winters in the Greenland Sea. These waters remember ice ages and warm periods, volcanic eruptions and changes in the Earth's orbit, atmospheric compositions that existed before the Industrial Revolution, before agriculture, before human civilization itself. But the deep ocean's memory extends far beyond even these remarkable timescales. Embedded in the sediments that carpet the ocean floor lie the most ancient memories of all, layer upon layer of accumulated particles that have been settling to the bottom for millions of years. These sediments are like the pages of Earth's autobiography, written in the shells of microscopic organisms, in dust from distant continents, in the chemical signatures of ancient atmospheres. Let's imagine ourselves now as time travelers, examining these sedimentary archives that speak of unimaginably distant pasts. Each layer tells a story of what the ocean was like when it was deposited. The shells of tiny marine organisms called foraminifera, no bigger than grains of sand, preserve the temperature and chemistry of the seawater in which they lived. By analyzing the isotopic composition of these shells, scientists can reconstruct ocean temperatures from millions of years ago, creating detailed records of how climate has changed over geological time. These tiny shells also record the ocean's memory of ice ages with extraordinary precision. During glacial periods, when vast ice sheets covered much of North America and northern Europe, the isotopic composition of seawater changed in predictable ways. The ocean remembers each ice age, each interglacial warm period, in the chemical signatures preserved in these microscopic archives. Perhaps most remarkably, the deep ocean sediments preserve memories of catastrophic events that reshaped the entire planet. The asteroid impact that ended the age of dinosaurs 66 million ago left a distinctive layer in marine sediments worldwide, a thin band enriched in the element iridium, which is rare on Earth but common in asteroids. This layer is like a bookmark in Earth's memory, marking the transition between two great eras in the history of life. Massive volcanic eruptions also leave their mark in the deep ocean's memory. The Deccan Traps eruptions in India, which occurred around the same time as the dinosaur extinction, poured enormous amounts of lava and volcanic gases into the atmosphere. The chemical signature of these eruptions is preserved in marine sediments, allowing scientists to study the timing and environmental impact of these catastrophic events. The deep ocean also remembers periods of dramatic climate change that occurred long before humans existed. About 55 million years ago, during an event called the Paleocene-Eocene thermal maximum, global temperatures rose rapidly by 5 to 8 degrees Celsius. The ocean's memory of this event, preserved in deep-sea sediments, shows us how marine ecosystems responded to rapid warming, providing insights into how they might respond to current climate change. But perhaps the most profound memories preserved in the deep ocean are those of the evolution of life itself. The Great Oxidation Event, about 2.4 billion years ago, when oxygen-producing bacteria began to fundamentally change Earth's atmosphere, is recorded in the chemical composition of ancient marine sediments. The rise of complex life, the evolution of shells and skeletons, the diversification of marine ecosystems, all of these major events in Earth's biological history are preserved in the ocean's deep memory. Let's take a gentle stroll now into perhaps the most beautiful and poetic of the ocean's memory systems, the vast archives of ice that cap our planet's polar regions and crown its highest mountains. Here, in the frozen realm where water pauses in its endless circulation, some of the ocean's most pristine and detailed memories are preserved, locked away in crystalline structures that can maintain their secrets for hundreds of thousands of years. Imagine, if you will, standing on the edge of the Greenland ice sheet on a clear Arctic day. Stretching away from you in all directions lies a landscape of white that seems to extend to the very edge of the world. But this is not simply frozen water, it's frozen time, a vast library where each layer of ice represents a year, a season, sometimes even a single storm from the distant past. These ice sheets are born from the ocean's memory in the most elegant way imaginable. Water evaporates from the sea surface, rises into the atmosphere as invisible vapor, condenses into clouds, and falls as snow on the ice sheets and glaciers. But each snowflake carries with it the isotopic signature of its oceanic birthplace, the chemical fingerprint of the atmospheric conditions through which it traveled, the molecular memory of temperatures and pressures and wind patterns that guided its journey from sea to sky to ice. As snowfall accumulates year after year, these individual memories become compressed into ice, creating a chronological archive that can be read like the rings of an ancient tree. Each annual layer tells the story of that year's climate. Was it unusually warm or cold? Was there a major volcanic eruption that filled the atmosphere with particles? Did ocean currents shift in ways that changed precipitation patterns? But the memory preserved in ice extends far beyond simple temperature records. Volcanic eruptions, for instance, inject sulfuric acid into the atmosphere, and this acid eventually falls with the snow, creating distinctive chemical spikes in the ice record. By analyzing these volcanic signatures, scientists can reconstruct the history of major eruptions going back hundreds of thousands of years, learning about how volcanic activity has influenced climate over geological timescales. The ice also remembers the composition of ancient atmospheres with remarkable precision. Tiny bubbles of air become trapped in the ice as it forms, creating perfect samples of the atmosphere from when that layer was deposited. These air bubbles are like time capsules, preserving the exact concentrations of carbon dioxide, methane, and other greenhouse gases from thousands of years ago. Through these frozen atmospheric samples, the ice tells us the story of how human activities have changed our planet's atmosphere. The pre-industrial atmosphere, preserved in ice cores from before the widespread burning of fossil fuels, had a carbon dioxide concentration of about 280 parts per million. Today's atmosphere contains over 420 parts per million, and the ice cores show us exactly when this increase began and how rapidly it has accelerated. But perhaps the most poetic aspect of ice memory is how it connects the polar regions to tropical oceans through the great circulation patterns we've explored together. The isotopic composition of ice cores reflects not just local conditions, but ocean temperatures thousands of miles away. Changes in tropical sea surface temperatures alter evaporation patterns, which influence the isotopic composition of water vapor in the atmosphere, which ultimately gets preserved in polar ice. In this way, ice cores from Greenland and Antarctica serve as distant thermometers for the tropical oceans, recording changes in ocean circulation patterns that affected global climate. The ice remembers periods when the Gulf Stream was weaker or stronger, when monsoon patterns shifted, when ocean upwelling changed in ways that influenced marine productivity thousands of miles from the ice sheets. Let's zoom in now on one of the most remarkable discoveries from ice core research, the memory of abrupt climate changes that occurred in the past. For most of human history, we imagined climate change as a slow, gradual process. But the ice cores reveal a different story. They show us that climate can sometimes change dramatically in just a few years or even a few seasons. During the last ice age, for example, the ice cores record periods when temperatures in the North Atlantic region changed by 10 degrees Celsius or more in less than a decade. These rapid changes, called Dansgaardeusker events after the scientists who discovered them, involved dramatic reorganizations of ocean circulation patterns. The ice remembers these events in extraordinary detail, showing us how quickly the ocean-atmosphere system can shift from one stable state to another. Let's take a gentle stroll now along the pathways that complete the ocean's memory cycle, those ribbons of flowing water that we call rivers, streams, and springs. These are the arteries that return the ocean's memories to the sea, carrying with them new stories gathered from continents and mountains, from forests and grasslands, from the very heart of the land itself. Imagine, if you will, following a single drop of water on its journey from an alpine lake, down through mountain streams, into rivers that grow wider and more meandering as they approach the sea. This drop carries within it not just the memory of the cloud from which it fell, but also the accumulated memories of every landscape it has touched, every rock it has weathered, every living thing it has encountered on its journey home to the ocean. This is how the ocean refreshes and updates its memory, through the constant return of water that has traveled across the continents, gathering new information, new chemical signatures, new stories to add to the vast library of the sea. Every river that flows into the ocean is like a messenger, bringing news from distant lands, reports from the continental interior about climate patterns, geological processes, and the ever-changing chemistry of life on land. Consider the mighty Amazon River, that great highway of memory flowing through the heart of South America. The water that eventually reaches the Atlantic has traveled thousands of miles, beginning as snowmelt high in the Andes Mountains, gathering tributaries from rainforests where biodiversity reaches its maximum expression on our planet. Each tributary adds its own signature to the river's chemical memory: the white waters that flow from mountain erosion, the black waters stained with organic compounds from tropical forests, the clear waters that spring from ancient geological formations. By the time this water reaches the ocean, it carries within its molecular structure the memory of an entire continent. The isotopic composition of the water reflects the elevation where it originated, the temperature and humidity of the forests through which it flowed, the geological history of the landscapes it drained. The dissolved minerals tell stories of weathering processes in different climatic zones, from tropical highland to lowland rainforest to vast seasonal wetlands. The ocean reads these riverine messages with extraordinary sensitivity. Scientists can detect the influence of major rivers hundreds of miles offshore, where their distinctive chemical signatures can still be distinguished from the surrounding seawater. The Amazon plume, for instance, creates a vast lens of relatively fresh water that extends far into the Atlantic, carrying the memory of South American climate patterns into the heart of the ocean basin. But rivers don't just carry the memory of natural processes, they also bring news of human activities to the ocean's vast library. Agricultural runoff carries the chemical signatures of fertilizers and pesticides. Urban rivers transport the complex chemistry of industrial processes and sewage treatment. Mining operations release distinctive trace metals that become part of the riverine message to the sea. In this way, the ocean's memory has become increasingly complex in recent centuries, as human activities have added new chapters to the stories that rivers tell. The ocean now remembers the Industrial Revolution through the heavy metals carried by rivers, the agricultural revolution through changes in nutrient concentrations, the plastic age through synthetic polymers that will persist in marine sediments for geological timescales. Let's follow now a very different type of water on its journey to the sea: the ancient groundwater that emerges from deep springs, carrying memories that span not years or decades, but centuries or millennia. Imagine water that fell as rain during the Little Ice Age, percolating slowly through rock formations, gathering dissolved minerals as it travels through underground aquifers, finally emerging from a spring after centuries in the subterranean darkness. This groundwater carries the isotopic signature of the climate that existed when it first entered the Earth, a molecular memory of precipitation patterns, temperature, and atmospheric composition from hundreds of years ago. When this ancient water finally reaches the ocean, it brings news of climate states that existed long before human instrumental records began. Some groundwater is even more ancient, carrying memories that stretch back tens of thousands of years. In certain desert regions, springs emerge that contain water that fell during the last ice age, when these now arid landscapes were verdant grasslands under very different climate conditions. This fossil water brings to the ocean the isotopic memory of Ice Age climate, serving as a direct connection between present-day seas and the very different world that existed during the last glacial maximum. Rivers also serve as the ocean's memory of seasonal cycles, carrying the rhythm of wet and dry seasons, snowmelt and drought, from continental interiors to coastal waters. The timing and magnitude of river flows reflect precipitation patterns that are ultimately controlled by ocean temperature and circulation patterns, creating a feedback loop where the ocean's memory influences the very processes that update and refresh that memory. Monsoon systems provide perhaps the most dramatic example of this feedback between oceanic memory and continental water cycles. The seasonal heating and cooling of ocean surfaces drives atmospheric circulation patterns that bring monsoon rains to vast areas of Africa, Asia, and Australia. These rains gather on the continents and return to the ocean via rivers, carrying with them the chemical and isotopic signatures that help the ocean remember the strength and timing of monsoon seasons. The memory carried by rivers is also biological, encoded in the organic molecules and nutrients that flow from terrestrial ecosystems into marine environments. Forest streams carry dissolved organic carbon that reflects the productivity and health of woodland ecosystems. Grassland rivers transport different ratios of nutrients that speak to the chemical cycles of prairie ecosystems. Even urban rivers carry biological memories in the form of treated sewage that reflects the metabolism of human populations. As rivers approach the ocean, they often create some of the most biologically productive environments on our planet. River deltas and estuaries are places where terrestrial and marine memories mix and merge, creating complex chemical gradients that support incredibly diverse ecosystems. The mixing of fresh and salt water creates unique conditions that many marine organisms depend on for reproduction and early development. These coastal mixing zones are also where the ocean begins to process and integrate the new memories that rivers bring. The chemical signatures of river water are gradually diluted and mixed with seawater, but they don't disappear. Instead, they become part of the ocean's vast chemical library, adding new information to the growing archive of environmental conditions and changes. Let's take one final gentle stroll together through the magnificent tapestry we've been weaving. This grand vision of the ocean as a planetary memory system that connects every drop of water on Earth in an eternal cycle of circulation, storage, and renewal. As we bring our exploration to a peaceful close, let's step back and contemplate the profound interconnectedness that water's memory reveals to us. Imagine, if you will, that you could somehow see all of Earth's water in motion at once. Every ocean current, every cloud formation, every river flow, every underground stream. Picture this as a vast, three-dimensional mandala of moving water, pulsing with the rhythms of seasons and tides, breathing with the great circulation patterns that span ocean basins, shimmering with the constant exchange between liquid and vapor, between surface and depth, between the immediate present and the deep memories of geological time. In this grand vision, you would see that there is really no such thing as separate bodies of water on our planet. The Pacific and Atlantic, the Arctic Ocean and the Mediterranean Sea, the Amazon River and the Mississippi, the groundwater beneath your feet and the clouds above your head. All of these are simply different manifestations of one great water system, one planetary circulation that connects every place and every time in an endless dance of molecular memory. The water in your morning coffee may have fallen as snow on the Himalayas last winter, then melted and flowed through rivers to the Bay of Bengal, where it evaporated and joined the monsoon clouds that brought rain to forests thousands of miles away. A water molecule in that coffee might have spent decades in deep ocean currents, carrying the memory of Antarctic ice to tropical seas, then risen to the surface where it evaporated again and began a new chapter in its endless journey. This is perhaps the most profound lesson that the ocean's memory teaches us, that everything is connected through the medium of water. The rain that falls in your garden carries isotopic signatures from evaporation that occurred in distant oceans. The rivers near your home eventually carry those same water molecules back to the sea, where they join currents that may transport them to the opposite side of the planet. Through water's memory, we can trace connections that span not just geography, but time itself. The water you drink today may have been part of the clouds that watered the gardens of ancient civilizations, may have flowed through rivers that carved the Grand Canyon, may have been locked in glacial ice during the last ice age. Every sip connects you to the deep history of our planet, to climate cycles that operated long before humans existed, to the very origins of life in the ancient seas. But the ocean's memory also reveals to us our own impact on this planetary water system. The chemical signatures that human activities have added to the water cycle, the excess carbon dioxide from burning fossil fuels, the synthetic chemicals from industrial processes, the plastic particles from our throwaway culture, these too become part of the ocean's memory, carried by currents and preserved in sediments for future generations to discover. In this way, we are all participants in the ocean's memory system. Every action that affects water quality, every decision that influences climate, every choice that alters the chemistry of our rivers and streams becomes part of the vast archive that the ocean is constantly building. We are writing our own chapter in the ocean's memory, adding our own signatures to the isotopic records that future scientists will read to understand how the water cycle changed during the early 21st century. Yet the ocean's memory also offers us hope and perspective. The same circulation patterns that now carry the signatures of human impact have carried the memories of countless environmental changes throughout Earth's history. The ocean has witnessed ice ages and warm periods, asteroid impacts and volcanic catastrophes, the rise and fall of different forms of life. Through all of these changes, the water cycle has continued, adapting and adjusting, carrying forward the memories that help us understand how our planet's systems respond to change. The ocean teaches us about resilience through its memory of recovery from past environmental crises. The chemical records preserved in marine sediments show us how ocean ecosystems have bounced back from mass extinctions, how circulation patterns have reorganized after major climate changes, how life has adapted to dramatically different atmospheric and oceanic conditions. As we conclude our gentle journey through the ocean's memory palace, let's contemplate one final beautiful truth that emerges from understanding water's ability to remember. Every time you drink a glass of water, every time you feel rain on your skin, every time you watch waves break on a shore, you are participating in something ancient and eternal, a planetary circulation system that has been operating for billions of years, connecting all life through the shared medium of water. The isotopes in your body's water connect you to distant oceans and ancient ice sheets. The water that flows through your cells carries molecular memories of evaporation and condensation, of deep ocean currents and mountain springs. You are quite literally made of the ocean's memory, constructed from water molecules that have traveled the world and experienced the full range of conditions that our planet can offer. And so, dear companions of this gentle evening journey, we find ourselves at the end of our contemplative stroll through the ocean's vast memory palace. As the minutes have passed while we've been together, water somewhere on our planet has been evaporating from warm seas, condensing in high clouds, falling as rain on distant mountains, and beginning new journeys that will carry today's atmospheric conditions into tomorrow's oceanic memories. I'm curious now to circle back to where we began. Where are you in this moment, and what time has it become in your corner of our water world? Whether you're listening in the pre-dawn darkness with the first hints of light touching your horizon, or deep in the peaceful hours of late night when the world around you has settled into quietude, you are connected through water's eternal circulation to every other place and time. If you're near a window, perhaps you can glimpse some manifestation of the water cycle we've explored together. Clouds drifting across the night sky, carrying their isotopic memories from distant evaporation, rain pattering gently against glass, each drop bearing chemical signatures from its atmospheric journey, or simply the humid air that surrounds you, invisible water vapor that connects your immediate environment to the vast oceanic systems we've contemplated. Thank you, truly and warmly, for sharing this peaceful exploration with me. Thank you for your patience as we meandered through concepts that span from the molecular to the planetary, from the immediate to the geological. Thank you for your openness to wonder, for your willingness to imagine water not just as a simple substance, but as the keeper of our planet's memories, the connector of all places and times in one grand circulation of remembrance. The ocean's memory teaches us something profound about continuity and connection. In a world that often feels fragmented and fast-paced, there is something deeply comforting in knowing that we are all part of this ancient system, this patient circulation that has been operating since the earliest days of our planet. Every breath you take, every sip of water you drink, connects you to ice sheets and tropical seas, to mountain springs and deep ocean trenches, to the molecular memories that span geological time. As you settle into sleep tonight, perhaps you'll carry with you this sense of being held by something vast and enduring. The water in your body connects you to all other water on Earth, making you a temporary participant in circulation patterns that dwarf human timescales. You are made of ancient starlight and ocean memory, of raindrops and river flows, of isotopic signatures that tell stories spanning millions of years. In the deepest currents of the ocean, in the slow circulation patterns that take centuries to complete their cycles, water continues its patient work of carrying memories across our blue planet. Some of that water remembers volcanic eruptions from before human civilization began. Some carries the thermal memory of ice ages and warm periods that shaped the evolution of life itself, and some now carries the new memories of our current era, the chemical signatures of how water's circulation is changing in response to human activities. Tonight, as you drift toward dreams, you join this eternal circulation in the most peaceful way possible, simply by being part of the water world that surrounds and sustains us all. Your breath adds water vapor to the atmosphere. Your body temporarily hosts water molecules that tomorrow may begin new journeys to distant seas. You are, in this moment, both a reader of the ocean's memory and a contributor to its ever-growing archive. May your dreams be filled with the gentle motion of currents and tides, with the quiet circulation of memory through water that connects all times and places. May you rest peacefully in the knowledge that you are part of something ancient and beautiful and enduring, the endless dance of water that makes our blue planet the living world we treasure. Good night, fellow travelers of this remarkable water world. Until we meet again for another gentle journey of discovery, may you rest well in the patient embrace of the ocean's eternal memory.